Good afternoon, everybody. So it's 2:40. We are going to get started. We are from Tata Communications. Our team is here. We are going to present today a very futuristic concept for optimizing enterprise networking scenarios and optimizing their general operating model in terms of what runs on the edge, how it can be optimized, what are the different ways to do it, and how open source tools will play a larger role in that story. So that's what we're going to present. And the topic itself is multi-access services edge. Before I go into the edge story itself, wanted to spend a few minutes about Tata Communications. This is one of first time we're doing this at an LFN event, so I thought it was a good idea to do a intro before we actually go into the topic. So if you look at Tata Communications, it's a global telecom services provider company, but we're focused on doing digital transformation for enterprises. So we enable it, we drive it, we execute it, we lifecycle manage it. So our overall goal is driving digital transformation in the ecosystem. But if you look at the Tata as a brand, there's only one data point that you want to remember. If there is any brand in the global industry today that's been highly successful for over 150 years. Think about that for a second. A lot of brands come and go over the years. But the brand of Tata stood tall until today, over 150 years. Still doing $100 billion business over a year, and it's present in a lot of different countries and employing over 1 million people, right? 150 plus countries. So that's one brand that we're all proud of about Tata. Like a lot of for-profit companies, a lot of what Tata's profit goes towards social services in India and other parts of the world. So this brand stands out tall today. So just want to give you that view. There are a couple of companies, obviously you probably heard about Tata Consultancy Services. It's one of our sister companies. Doing very successful in the SI integration space. Tata Communications, on the other hand, is a digital fabric. We are the infrastructure company within the Tata group of companies. So what do we do for a living? I hope this picture is clear. So we connect the world together. So we connect the continents together, countries together, people together. Now in the space of IoT, we connect a lot of things together. What you see here, a lot of subsea cables, high bandwidth, terabits per second, multiple terabits per second, high bandwidth, express highways connecting the entire world together. This is, in fact, is our digital fabric. Everything runs on it today. If those cables don't exist, internet don't exist today. So that's how crucial this is for everything that we do today in our daily lives. Couple of data points here. 32%, that's almost 1/3 of all internet routes runs on Tata Communications network today. Think about that for a second, the scale. And on the voice enablement side, we are number 1 in the world today. There is a big difference between a voice enablement versus providing internet connectivity. Internet is unregulated market, whereas traditional voice is completely regulated. So getting a voice enablement in any country, you have to go through a lot of regulatory hooplas to get there, and we enable that for 100 plus countries today. Why is this important? In the world of where we are today, in the virtual world and otherwise, every Teams call, every Zoom call you make, you dial into, all of that requires a voice infrastructure on which this can run. So Tata Communication provides that infrastructure. So when you dial into Zoom or any other video conferencing calls, there is a voice enablement that's needed for that, and we provide that today. So for every enterprise out there who is doing digital transformation, voice networking and data networking both are key, and that's what we do. And we do that in a very good manner. As you can see, Gartner Magic Quadrant leadership status for us. Let's see what else we do. This is a customer of ours for 20 plus years. If you guys follow Formula One, if I can give you an example of what we do and how we do, this is a couple of pictures around the Montreal F1 that happened a few months ago. There are hundreds of cameras in the racetrack, 4K, 8K type of cameras. All of the data is aggregated and collected at the edge data center that we host. And then it's all shipped to London for production studio. And then it gets produced, and then it put right back into a content delivery network, a worldwide content delivery network. And those content will hit every household in a TV or any other devices today. So the entire operation happens in a split millisecond, or maybe in a nanosecond in some cases. Think about a failure during a race event, failure of a networking. You can't afford that. So we've been doing that very successfully over a number of years, and we are proud of that. We are proud of our partnership with F1 as well. So I want to give you that view, the scale and the reliability at which we operate worldwide. In terms of what we offer to our enterprise customer in terms of our entire product portfolio, as you know, all service providers are now transforming digitally their entire product ecosystem. At Tata Communications, we are at the forefront of that transformation. As you can see, the entire central layer is platform as a service. Every product that we offer today, we offer that as a PaaS, as a platform as a service. So that means it's fully orchestrated end-to-end. A lot of automation comes into play. So it makes the user experience much more easier in the way that we see in some of the retail user experience, if you will. So that's our goal, bringing the entire service together as platform of service rather than having siloed products and the siloed experience. If you're a customer buying 5 different products from Tata, I want to make sure you have experiences unified across all our platforms. So that's what we strive to do. Why is this important? When we talk about digital transformation, enabling and driving it for our enterprise customers, if we don't do that in-house very well, we won't be able to do it for the customers. So we make sure we do that very well in-house within our enterprise, and then we take that experience to our customers. So that's our goal, and that's what we do. In terms of our additional portfolio, as you can see, collaboration portfolio, networking, mobility, IoT, we do a lot of offering there. Don't want to spend too much time in there. In terms of industry credibility, we've been a Gartner Magic Quadrant leader for many years, and we continue to improve our position year over year. And there are a multitude of awards and certifications, as you can see in the slide. And an NPS score, which is basically a customer's rating us, and a score of 80 is fantastic. A lot of other service providers out there with very, very low scores. So we are proud of the score that we have, and we thank you for our customers for rating us that high. So with that, by the way, you can see multiple analyst reports. We figure in all of those. So that's all useful for our industry credibility. Today, that's the intro piece of it. So we're going to talk about the next big thing. As you know, you can see this, you read this for the last couple of years now. The next big battlefront in networking or in the internet is edge. How do we evolve the edge? How do we make sure the edge is helping the business outcomes, right? All of the different industries, how all of those use cases are driven and how they are brought to the business outcomes for individual customers. So we have a concept that we'll talk about that today. So with that, I will bring my technology expert, Arunava, to walk us through the edge story.
Thanks, Ramesh.
Thank you.
Yeah. I hope I'm audible. Yes. Yeah. It's always difficult after lunch, to have this. While we think, like, I think for the last couple of days you're talking about edge in multiple ways and forms, right? Kubernetes and various forms of how we can do orchestration. In our view, edge is not only about edge compute. Edge is not only about edge security. Edge is not about only edge orchestration, right? It's equally important that we think about edge as connectivity, a converged connectivity mechanism for edge. So what we're going to talk about today is a converged connectivity from an edge standpoint. So we'll talk about a blueprint and one of our customer deployment that we have done recently. We believe that this story of multi-access services edge or converged connectivity at the edge is going to go a long way, right, as an operating model. So this is the opportunity we are taking to introduce this particular concept as an operating model. And there we go. Okay. So why this particular concept came in? These are some of the challenges that we see across customers. These are not something we picked up from the general trend analyst report and publishing it here. This is about speaking with customers, interacting with our customers, and seeing how it emerges. Some of this stuff, for example, multi-service. What does multi-service mean in the context of edge? It's just not about hosting containers or microservices on the edge. It's about how that particular edge is interacting with the rest of the world, because where they are talking would be different. It could be Azure, AWS, captive data center, open internet, a 5G MVNE network. It could be anything of that sort, right? Edge cannot work on its own. It needs a hub to operate. So how do we basically do an optimized multi-services connectivity is a big question mark, right? Because it's too disparate right now. The other thing that we see is at the edge, whenever we talk about latency-proven applications, we talk about AR, VR, holographic rendering, and various other applications which are latency sensitive, which are bandwidth savvy. And hence, we need to have a platform or a connectivity mechanism to proliferate that edge to connect to the rest of the world better, right? So latency is one big thing, and we'll talk about how we are solving that. And of course, when it comes to edge, it's all about capillarity, right? The number of nodes that we're going to put up, and hence automation becomes too critical aspect of it, right? Bandwidth savvy you spoke about. A lot of applications right now are demanding that kind of heavy capacity, which are image-based. Agility, which is essentially around turnaround time. Because edges are nodes which you kind of spin up. How fast we can spin up those nodes is all about agility, right? So that's where agility and automation goes hand in hand. Scalability, it needs to have a scale-out model. Today, the problem is a service provider, whoever that is, who look at edge deployment, right? It's a heavy lifting because there's a massive logistics. You need to understand the feasibility of the location, put a bare metal, and then turn up those microservices. And then whenever there's a scale out, and we all know the chip shortage and so on and so forth, the whole supply chain at the back of it, doing a scale out is not an easy way. How we can preempt some of them in order to optimize turnaround time. On demand, burst in, burst up. It is not that all applications will consume services at the same capacity. They would essentially have different demand or requirement at different point in time. So how do I essentially have the same infrastructure at the edge, but able to scale up and down? That's the on-demand part of it. And most importantly, standardization and consistency. we should be able to do it, whatever we are talking here, across the globe, same way. So what we're going to present today, in some sense, is a reference architecture for a global deployment so that we don't change what we are talking about, geography by geography. With that, I know it's a busy slide. Is this visible at the back? Kind of. Okay. I'll try and talk about it. This is our view on the holistic edge. I know there are different views of edge. As we say, edge comes from a compute perspective, edge comes from SDN perspective, edge comes from orchestration, and we are coming from a multi-services edge from a converged infrastructure standpoint. But this is more of a holistic edge, right? If you see at the bottom, I'll read it out for the benefit of all. We are talking about an HCI edge, a hyper-converged infrastructure edge. It could be a bare metal, which runs microservices or containers on top of that, right? The containers could be an AR/VR container. It could be a holocast container. It could be a 5G data plane or a mobile management container. It could be a third-party app. It could be a HubSpot. It could be any other open source ERP or CRM that's available in the market. It could also be an SDN or an SD-WAN CNF, right? Of any vendor, right? And of course, there could be multiple other analytics applications which runs on the edge, which typically is the de facto. Things like Spark, Joule, and various other open source analytics platform which runs on it. This is an overall view or concept that we are talking about. And all of this middle layer, which we call as HCI edge, is something which runs on a bare metal, but essentially we can facilitate that, right? That's part of the overall edge construct. However, only with that HCI edge, which is nothing but a scale-out bare metal model, it's not enough, because you will have footprints all over the world, right, for a specific deployment. How do I enable automation on top of that? That's where we basically have brought in Kubernetes on top of that to do the scheduling and the management of that whole HCI edge containerized service. It can run on Diego, run on Docker, could be running on any of those container engines. But the idea is this particular orchestration, which you see, which is mentioned as ISO Edge Pass, is hosted somewhere centrally, maybe a couple of locations. But your edge can be deployed anywhere in the world, right? And obviously, as we said, it runs on Kubernetes. It gets feed from various other open source infrastructure as a code services, Jenkins, Ansible, some of them. They get feed from Project Harbor, GitLab, any of those source repositories, right? So that's how the overall infrastructure automation / orchestration that we are talking about comes into picture, which governs this central piece, which is the HCI edge, right? Now, while we are saying that, one of the most critical element, I think there are sessions which has happened on security at the edge. Now, that is also becoming a big topic, whether it's an automotive telemetry or it could be any other use cases, the security becomes important. So what we are saying, if you see the right section, these are service mesh. It could be Istio, could be Envoy, could be anything of that sort. So essentially, this whole HCI edge infrastructure is wrapped around with the security services, be it an identity access management services, or it could be a key vault or anything of that sort. So net-net, what we're saying here is we have laid the foundation for the microservices at the edge for supporting all those critical apps. We are talking about an orchestration on top, and then the security at the edge, right? Which is essentially around identity access and key vault. But now comes the most important piece, as I was saying, multi-access service edge, what that means. As we say all of these problems, there are various kind of underlays, right? It could be an internet, could be an MPLS, could be an Ethernet, various kind of services. It could be any of these clouds, could be a SaaS application. So what we are trying to do here is take the edge and then connect on single port, a single port, to connect to all this ecosystem, whether it's a SaaS, whether it is multi-cloud, whether it's in any open hyperscaler infrastructure, could be running a database, could be running an SDN headend, could be running any of those database or object storage, depending on what applications you're running on the edge. As I said, edge is just not standalone. So by virtue of that particular port, single port, we are able to connect on that single port logically all these connections. That's what multi-access service edge construct comes in. Making sense? So this becomes a hub, and these spokes are everywhere, and we are covering with a single hardware, with a single port. With that, a subset of this we have deployed in a large customer. If you see this, the customer has 5 sites, enterprise has 5 sites. Each of these sites, we are having a single SFP port. And that single port is logically connected to multiple clouds. In this case, it's Azure, MPLS, in some cases, Internet. But imagine this is a single port per site, which is doing the trick. Now, if we proliferate this, these customer edge, if you extend this to hub or edge, it's the same deployment. So every edge deployment will look like this, we believe. This is what a classic multi-access service edge infrastructure means. By having this, what are we gaining? On demand, we can shift between services, MPLS, Internet, different scale, different capacity, scale up, scale down, because we can configure this. Single port. So it's an optimized hardware, optimized cost. There's not much hardware required at all at the edge, right? But still able to connect in multiple places. Unified assurance, because a single source of truth. Globally referenceable, as we see. We had US, Singapore, and so locations. Is exactly the same reference architecture done everywhere. We have created enough resiliency to do that, so diversity, building diversity is quite easy because it's all logical, and we can use our own connections or our partner connections. It doesn't really matter. So there is no limit in terms of how that architecture can be referenced. And of course, one of the biggest things is cost effectiveness and quick turnaround time, faster GTM. Key, absolute key. So from that standpoint, with the current scenario of chip shortage, et cetera, it makes a lot of sense to consolidate, reduce the hardware footprint, but still able to make all those microservices working in the edge to connect to wherever they want to go, faster, better, cheaper. Right? Because these are all logical connections. And what I want you to take home as a summary of this multi-access services edge construct is that this is a standardized architecture. We believe we'll be able to replicate in a lot more places. This will become a future operating model for connectivity at the edge. It's a standard architecture for on-premise, for service provider, for data center, wherever. Because we believe that edge is just like a branch or just any other form factor that the customer would have. It improves user experience. As we could see, all of these connections, we are doing it locally, regionally. When we say US, we will do our breakout or connections in US, be it Azure, AWS, or our Internet or MPLS, we do it locally, optimized latency, right? Similarly, if we do it in Singapore, we will do it locally. So we will basically keep the traffic or routes as much local, right? By which we will be able to improve that latency or optimize latency and have an app experience. There's a construct called dynamic roaming boost, maybe for another session, which essentially helps this, right? And last but not the least, single point of delivery and assurance across the nodes across the globe. Single provider who is taking care of HCI edge, orchestration, and then the multi-access service edge as a bedrock, right? And cloud agnostic, because we see a lot of deployments happening multi-cloud, a lot of applications in Google, AWS, Azure, private data center, et cetera. And as you could see in the deployment that we shown, there was Azure, and there was GVPN, and there was a DIA, but it does not really matter. It could be an Oracle cloud, it could be an AWS, it could be a Salesforce, it could be any cloud. We would connect the same way, whichever that cloud is, with the same predictability and same cost structure. Because you're talking about a single SFP per location, which connects to all of that. So really the cost model doesn't change. So it really does not matter what that hub of that edge is. We're going to do that or repeat that time and again at the same cost structure model, right, as a scale out. So with that, we'll have, if there are any specific questions, glad to get your feedback. I know it was quite a bit in a short period of time, but happy to connect offline or if there are any specific questions you guys may have. Sure.
For SD-WAN, are you using a third-party product for that, or is it something you built yourself?
If you can just repeat, I just.
The SD-WAN is.
Oh, for the SD-WAN? Okay. Your question is?
For SD-WAN, do you use a third-party product to help deliver on that, or
This is the one that you're talking
yourself?
about, right? Sorry.
Well, you got the
Oh, okay.
flyers that
All right.
mention
Okay.
SD-WAN.
Sure.
So.
No, okay, get it. So that's a generic one. So we use multiple OEMs, commercial OEMs for doing SD-WAN globally in different form factor. In this, what we are essentially talking about, in this construct, it doesn't really matter. It could be an open daylight. It could be something running on Sonic. I'm sure you guys have attended the Sonic and the SAI and all of that stuff in the last few days. It really does not matter because this is an infrastructure enablement. I can run any CNF on any OS, any daemon, the same way time and again, right? That's the edge story. But we, of course, are engaged with multiple partnerships with multiple SD-WAN providers who are commercial. We basically are quite a market-leading player in that construct. And for us, SD-WAN is just not SD-WAN. We also look at SDDC, SD access, SD LAN, and all of that as a construct, and we are engaged with multiple providers in different space. So that's what the brochure is. But in this construct, we are opening it up and encourage people to look at maybe even open source, and we become the infrastructure enabler. Does that answer your question? Thank you. Yeah.
My question is that you talked about Kubernetes, Edge, and all that stuff. So do you provide Kubernetes as a service to your customers? I mean, is it that you have multiple edge locations with a lot of compute and then you could?
Great question. Yeah. And I know exactly where you're coming from. So we have this construct called Edge Pass, which is mainly to substantiate private 5G and edge compute as a service. If you see all these microservices or containers running, whether it's Drool or Flink or Spark or anything of that sort that we are talking about, Redis or Memcached, anything, those are customer-hosted applications. But the containerized infrastructure, running the Docker daemon and spinning up the containers, doing the Kubernetes networking construct, right? Bringing up the pods, the nodes, et cetera, and orchestrating it centrally, yes. So that's where the orchestration comes in. And if you really look at it, a lot of this space is covered by us today, right? I mean, as I said, it's more from an infrastructure enablement perspective.
How many edge locations do you have?
See, again, it's a very demand basis, right? Because it's all customer-specific deployments, right? It's not because it has to reach the economies of scale. And typically, a lot of these edge deployments are happening on-prem. Okay? It's not necessarily a service provider hosted edge because it needs a different operating model and a different economies of scale, and hence it is driven by customers.
Okay.
Any further questions? Happy to clarify. Feel free if you can talk offline on any of the unanswered point of view. Thanks for your participation. Pleasure to talk to all you guys today, and look forward.
Thank you.
Thank you.